In the previous lecture, we were discussing about second order differential equation with constant coefficients and their roots. For example, if we have a differential equation of this kind, a y double dash b y dash plus y equal to 0. Then I told you what is auxiliary equation or characteristic equation. We need to find first the characteristic equation. Let me admit these people. So I told you we can write this differential equation in this form: a d square plus b d plus c times y of x is equal to 0. This was basically, we were discussing second order, linear second order ODE plus homogeneous. It is a homogeneous ODE because the right hand side is 0. Now, how to solve it? First of all, we shall write the characteristic equation. I hope you know how to write the characteristic equation. If someone doesn't know this, you can see in my previous lecture. So characteristic equation, or we call it auxiliary equation. How to write it? am square plus bm plus c is equal to 0. Now this is what? This is basically a polynomial equation of degree 2. Is a polynomial equation of degree 2. It must have at most 2 roots. We discussed 2 cases in the previous lecture. The case 1, when the roots are real and distinct. What was the case in this situation? B square minus 4ac must be greater than 0. Case 2, when the roots are real and repeated. In this case, we have b square minus 4ac is equal to 0. So we have discussed these 2 cases in the previous lecture. Now, the case 3, when the roots are complex. In fact, they are complex conjugate of each other. Okay. I hope you know complex roots always exist in pairs, plus minus. So we assume that the roots here of this equation, this auxiliary equation or characteristic equation, we assume that the roots are alpha plus iota beta and alpha minus iota beta, or simply we can write alpha plus minus iota beta, because they always exist in pairs. Now, whenever we have this case, the general solution of that second order differential equation can be written in this form in case 3. The general solution of the given second order linear homogeneous ODE is defined by y of x is equal to, as we defined for the previous 2 cases, it is C1. Someone is waiting for the meeting. C1 e raised power alpha plus iota beta plus C2 e raised power alpha plus iota beta times x and then alpha plus iota beta, alpha minus iota beta times x. Now, from this solution, you can see that e raised power alpha x and e raised power alpha x here, they are both common. We can take them out of these two terms, and we can write simply C1 e raised power iota beta plus C2 e raised power minus iota beta. So this could be the general solution of that differential equation, but we can simplify this solution further by using some exponential and trigonometric identities. Now, we know that, I hope you know, we know that e raised power iota theta, it can be written as cosine of theta plus iota sine theta. Okay, this is an identity which basically relates cosine and exponential, trigonometric, and these cosine, sine, and exponential function. And here we have iota in the exponential of theta. I hope you know this identity. Now, if we have here e raised power iota beta and e raised power minus iota beta, by using this identity, we can write e raised power iota beta is equal to cosine of, यहाँ पे we must have x as well. Sorry for the mistake, यहाँ पे x होगा. Then e raised power iota beta x, we must have cos of beta x plus iota sine of beta x. Similarly, we can write e raised power negative iota beta x is equal to cosine of beta x minus iota sine beta x. Due to this negative sign, we have a negative sign here. And you know that the cosine function is an even function. Negative sign यहाँ पे जो है वो that will be disappeared. Now, using these two identities, if we add these two equations or identities from, if we call it 1 and we call it 2, then 1 plus 2 gives us, if we add these two things, we have this plus this, 2 cosine 2 beta x, iota sine beta and minus iota sine beta x, ye cancel ho jayega. This will be cancelled out, and we definitely will get e raised power iota beta x plus e raised power negative iota beta x is equal to 2 cosine of beta x. This thing. Similarly, if we subtract these two equations, 1 from 2 or 2 from 1, 1 minus 2, this will give us this minus this, e raised power iota beta x minus e raised power minus iota beta x is equal to, in this case, these two expressions, cos beta x, negative cos beta x, ये दोनों cancel हो जाएंगे, and we'll get 2 iota sine beta x. So this must be equal to 2 iota sine beta x. These we call it this is equation 3, and this is equation 4. I hope you can see it. If you have any question, you can ask me. Now, let's come back towards this general solution. General solution has this form. Now, in this general solution, if we assume that C1 is 1 and C2 is 2, okay, choosing C1 is equal to 1 and C2 is equal to 1 again, then this general solution will become, this will give us first solution, a particular solution, you can say that, e raised power alpha x times, अगर आप C1 और C2 दोनों को, if you choose them 1, then we will get e raised power iota beta x plus e raised power minus iota beta x. Okay. And from here, we can write this thing is equal to what? By using equation 3, this thing is equal to 2 cosine of beta x. So the solution will become e raised power alpha x times 2 cosine of beta x. This thing, this is the first solution. The second solution, if we choosing C1 is equal to 1 and C2 is equal to -1. In that case, the general solution or the second solution, we can write it in this form, e raised power alpha x. And using the equation 4, this one, if we choose C1 is equal to 1 and C2 is equal to 2, we'll definitely get here e raised power iota beta x negative e raised power negative iota beta x. Now using that equation 4, we can write the solution in this form. This is equal to what? It is 2 iota sine beta x. This. Now this solution is basically what? 2 times e raised power alpha x cosine of beta x. And this is ultimately 2 iota e raised power alpha x and sine beta x. Now these are two independent solutions of the given second order ODE. We know that if we have a solution of any ordinary differential equation, then its constant multiple is also a solution by using the principle of superposition. So we don't need these two constants. Then the general solution, solution of the given ODE can also be written in this form, which is more simplified form of the general solution as compared to the one which we have written earlier. So this is now y raised power x e raised power alpha x times C1 cos beta x plus C2, and then here e raised power alpha and sine beta x. Sine beta x. So this is the required general solution, which is in the more simplified form for the given differential equation in the case 3, when we will get the complex conjugate roots of the auxiliary equation or characteristic equation. I hope you get it. If you have any question, you can ask me. What was the roots m? Roots alpha plus minus iota beta. This was the roots which are complex conjugate of each other. Then how to write the general solution? Alpha comes here e raised power alpha x, and then beta comes here C1 cos of beta x plus C2 sine of beta x. So alpha comes here, beta comes here in the cosine and sine functions. So this is a more simplified form of the general solution in the third case when the roots are complex conjugate of each other. Now let's do a couple of examples of all these three cases. If you have any question, you can ask me.
Sir, एक question था कि सर जब हम वो सुपरपोजिशन प्रिंसिपल लगा के आपने ये जनरल फॉर्म की इक्वेशन लिखी है, इसमें जो C1 और C2 है वो पिछले C1 C2 से डिफरेंट है?
डेफिनेटली डिफरेंट है.
ठीक है,
ठीक है. यहाँ पे आप C3 C4 कह रहे हैं आप इसको. जी जी बोलें.
सर आपने जो लास्ट में जनरल सॉल्यूशन निकाला है, इसमें हमने आयोटा से कैसे हमने हाउ डिड वी गेट रिड ऑफ आयोटा?
बेटा देखिए, मैंने आई टोल्ड यू वी यूज्ड दिस identity, this one. I hope you know this identity. You have already studied these kind of identities in, I think, A levels. E raised power iota theta is equal to cosine of theta plus iota sine theta. Okay. This identity is normally basically you see in your earlier classes, O levels, A levels, or metric FSC. So by using this identity, we are going to eliminate iota in the general solution. Previously, we have written this general solution, which was basically in the similar manner, we have written the general solution for the first two cases, case 1 and case 2. But here, in this expression, we have iota here. And you know, iota, basically, it create problems in the solution. So we try to eliminate this iota from this general solution. How to eliminate this? This is basically discussed here. What we did here, e raised power alpha x, we take it outside of this expression because there is no iota in this expression. And the rest of things we have written C1 e raised power iota beta x. And then from here, C2 e raised power minus iota beta x. ठीक है, अब ये expression है हमारे पास. Now we have iota in this thing. Now using this identity, we can write e raised power iota beta x into this form and e raised power minus iota beta x in this form. Okay. Now adding these two, we can write that e raised power iota beta x plus e raised power minus iota beta x is equal to 2 cosine of beta x. Now in this expression, we don't have iota here. Okay. Similarly, if we subtract these two equations, we get e raised power iota beta x minus e raised power minus iota beta x is equal to 2 iota sine beta x. Now, in this expression, there is iota, but this solution is basically, or this expression is a constant multiple of 2 iota. Now, by simplifying these expression according to this procedure, अब यहाँ पे general solution इसके equal था. By choosing, this is how we normally eliminate the, because if this is a general solution, this is a general solution for any arbitrary values of C1 and C2. C1 and C2 can take any values from the real numbers. Now, I am going to choose which I need to just to eliminate the iota from the general solution. So I chose C1 is equal to 1 and C2 is equal to 1. Why? So that I can apply, I can use that identity, equation 3 and 4. That's why I chose there C1 is equal to 1 and C2 is equal to 2, so that this inner expression where we have C1 and C2 here, C1 and C2, now they are eliminated. We have chosen their values 1, 1. Now this expression using that equation 3 can be written as 2 cosine of beta. Now this is your first case. This is your first solution. E raised power alpha x, 2 cosine of beta x, 2 e raised power alpha x cosine of beta x. Now, this is your actually the solution. Why I am going to eliminate this 2 here? Because I know that if a differential equation has a solution, then its constant multiple is also a solution. Okay, by using the principle of superposition. Now, I can choose this as a first solution, and similarly by choosing C1 is equal to 1 and C2 is equal to minus 1, again in that general solution, I can write this inner expression is equal to 2 iota sine beta x. Now there is iota here. I can eliminate this iota because I can write this solution in terms of 2 iota e raised power alpha and sine beta x. Now, actual solution is this, and this is the constant multiple of that solution. We can eliminate that constant. Now, by taking these two expression as the solution, as this is the first solution, this is the second solution. By using the principle of superposition again, I can write the linear combination of these two solutions as a general solution of the original given ODE. I hope you get it. If you have any further confusion, you can ask me.
No, sir. Thank you.
Okay. Now we are going to discuss a couple of examples of these 3 cases. Now, whatever the differential equation is, the general solution basically depends on the roots. What are the roots of the given differential equation? For example, if we have an ODE of this form, y double dash minus 3y dash plus 2y is equal to 0. Keep in your mind that the ODE should be homogeneous. You should have 0 on the right hand side. Okay. then we can use this technique to solve or to find the general solution. Now, from this equation, I can write it in this form: d square minus 3d plus 2 times y. Y of x is equal to 0, in fact. Why I write this differential equation in a first step in this form? Because this form basically makes it easy to write the characteristic or auxiliary equation. Now, characteristic equation or characteristic polynomial equation, in fact, or auxiliary polynomial equation is characteristic or auxiliary polynomial is what? Is, I can directly see from this, m square minus 3m plus 2 is equal to 0. Now, we have to find the roots of this polynomial equation. If we have a second degree polynomial, we must have two roots. If we have a third degree polynomial here, if we have a third order differential equation, we'll definitely get a third order polynomial here. If we have a fourth order equation here, we must have a fourth degree polynomial here. I hope you know that the number of roots of a polynomial, if it is of degree 2, then it must have at most 2 roots. If the degree of polynomial is 5, then that polynomial must have at most 5 roots. Now, we have to find now the roots of this polynomial by using any appropriate method. By using factorization, by using the quadratic formula, by using remainder theorem. I hope you know what is that remainder theorem. In this case, we can factorize here 2m minus m plus 2 is equal to 0. So I get m minus 1 and m minus 2 is equal to 0. So we get the roots equal to 1 and 2. Now, you can see that these two roots are real numbers and they are distinct. So this is the first case. How to write the general solution if we have real and distinct rules? Distinct roots, real and distinct. This was the first case. In this case, the general solution can be written in this form: y is equal to, basically, before writing the general solution, what we say that if there are two roots and both are distinct, we obtain two linearly independent solutions. The first solution is what? It is e raised power 1x, and the second solution is what? It is e raised power 2x. Here 1 and 2 are the roots of this characteristic equation. Now, if there are two roots, we obtain two linearly independent solutions of this second order ODE, homogeneous ODE. If we have two solutions, then by using principle of superposition, we can write the general solution of the given ODE. How? It is y, C1 y1 of x plus C2 y2 of x. So the general solution is C1 e raised power x plus C2 e raised power 2x. So this is the general solution of the given second order ODE, which involves two unknown parameters. And I already told you that if you have a second order ODE, then its general solution must have two parameters, two unknown parameters. I hope you get it. If you have any question, you can ask me.
सर अगर हमें C1 और C2 फाइंड करने को बोले तो हमें इनिशियल कंडीशंस दी होंगी?
Yes, if we want to find these C1 and C2, then we must have initial conditions. For example, the initial condition 1 is y of 0 is equal to maybe 1 and y dash of 0 is equal to 0. Maybe these two conditions, initial conditions, are given. Then how to find these constants? In order to use these boundary conditions, in order to use these initial conditions, What do we need? We need y at 0 is equal to 1 and y dash at 0. So we need to find its first derivative. So first derivative of that y of x is what? It is c1 e raised power x ka derivative, e raised power x, plus c2 e raised power 2x ka derivative, plus 2c2 e raised power 2x. This thing. Now we have y and y dash. Now we can use these initial conditions. Now by using first initial condition, y at 0 is equal to 1 means x key value 0 and y 1. We have to put it here in this expression. Let me put it for you. Now using the first initial condition y at 0 is equal to 1, it gives us 1 is equal to c1 plus c2 because e raised power x and e raised power 2x, e raised power 0, e raised power 0, 1 ho jayenge dono. We get first equation. Now the second y dash at 0 is equal to 0. It gives us, now we have to express, we have to insert x equal to 0 here. Y dash at 0 is what? 0 and e raised power 0, e raised power 0. What do we get here? We get 0 is equal to c1 plus 2c2. Now we obtain what? We obtain two equations in two unknowns, c1 and c2. We can solve these two equations simultaneously easily. I hope you know how to solve equations simultaneously. But when we have higher order differential equations, then we'll obtain more equations here. In that case, if, for example, if we have a order 5 differential equation, then we have to find 5 constants. And we have to, we will get here 5 equations in C1, C2, C3, C4, C5. In that case, who's this? Okay. Now, this linear system can be solved by using techniques which you have studied in linear algebra. We can write the augmented matrix of this corresponding linear system 1, 1, 1, 1, 2, 0. So this is your augmented matrix. Now solving this augmented matrix, I hope you know how to solve it. You know Gaussian elimination method, Gauss-Jordan elimination method, and there are other methods by finding inverse of this linear system. Means you can use all the techniques in linear algebra which you have already studied in order to solve this linear system and get the values of C1. You will after solving this linear system, you would get the value of C1 and C2. Then you can put these values in the general solution and you can get the particular solution, okay, which satisfy also the initial conditions. I hope you get it. If you have any other question, you can ask me. You get it?
Yes, sir, thank you.
Okay. Now, let me do a case when the roots will be repeated. Let's do another example. In that example, we have the equation we solve the differential equation 2y double dash minus 5y dash minus 3y. So in that case, this equation can be written in this form, minus 3, this one. In this case, the characteristic equation will become characteristic equation is now 2m squared minus 5m minus 3 is equal to 0. Now we can factorize it. Can we factorize it? It is 2m squared minus 6m plus m minus 3. Okay, I hope you get it. So from here we can get 2m. Just a second. Let me see that whether this has same roots. No, we are trying to discuss the case 2. In this case, we will not get the same roots. So let me change the equation again. Sorry for this thing. We are going to discuss the case 2 when the roots are repeated. So the equation I am going to consider, it is y double dash plus 8y dash plus 16y. So in this case, we can write ad square plus 8d plus 16. This and the auxiliary equation or the characteristic equation will be m square plus 8m plus 16 is equal to 0. We can see that this expression is basically m plus 4 whole square equal to 0. Now the roots are what? It is minus 2. Sorry, minus 4, not 2. Minus 4. And the second root, because it's repeated 2 times, so we must have 2 roots which are identical. So these roots are basically real and repeated. This is the second case we have discussed earlier in the previous lecture. When we have a second order differential equation, homogeneous with constant coefficients, if we obtain repeated roots, real and repeated, then how to write the general solution? I told you, we can write only the one solution because there is only one root which is repeated 2 times. So we can write only one solution, y1 of x e raised power minus 4x. How to find the second solution? How can we find the second solution? Anyone can tell me, please? I told you in the previous lecture. Yes, from Daniel, we can use the method of reduction of order. So what was that method? You can see in the previous lecture, but here I'm going to use directly the formula which we have derived. We can use that formula in order to find the second. I think यहाँ पे negative था. This was basically the formula in order to find this second solution. Is there a question in the chat window? Yes, reduction of order. Now, by using this expression or this formula, the formula was, I think, yes, I wrote it correctly. Now, we know the y1. What is y1? E raised power minus 4x. So we write it here, e raised power minus 4x, integral of e raised power integral of minus p of x. Now, what is p of x here in this case? P of x is basically, if we convert this differential equation into standard form, then p of x is basically the coefficient of y dash. So what do we have here? We have 8 dx divided by y1 square. Y1 is what? E raised power minus 4x. It's square. Then whole this thing will be integrated. Okay. Now, let me write it here so that you can see the steps, previous steps. Now, you can see that here in the denominator, we have minus 4 times 2. So it will become e raised power minus 8x. Or after integrating this, it is minus 8 dx integral. So it is also e raised power minus 8x. So these two things are identical, in fact. So y2 of x is what? It is e raised power minus 4x integral of e raised power minus 8x divided by e raised power minus 8x dx. So these two things will be cancelled out. What do we get here? We get 1 here. And the integral of 1 is what? X. So what do we get here? We get the second solution, which is basically x times the first solution. Or you can say that x power 1 times the first solution. This is your y1, in fact. Okay. You get it? If you have any question, you can ask me. Just remember that this is x power 1 e raised power minus 4x, which is already the y1. Now, in this example, yes,
नहीं आएगा
yes,
constant of integration.
constant of integration इस formula में हम नहीं लिखते. I hope you know. I told you in the previous lecture why we don't write constants here.
ठीक.
So we get first solution as a e raised power minus 4x and second solution as x e raised power 4x. Now we have two solutions. Now we can write a general solution of the given differential equation by writing the linear combination of the two solutions. The general solution in this case is what? It is y of x. It is a linear combination of c1 y1 of x plus c2 y2 of x. Okay. Now c1 e raised power first solution is e raised power minus 4x plus second solution is c2 x e raised power minus 4x. Now e raised power 4x is common, in fact, in both these expressions. So we can write c1 plus c2x times e raised power minus 4x. Here we have this c2x power 1. There's a question in the chat window. Sir, will the y2 solution always be of this form, x, y1? If we have second order linear homogeneous equation? Yes. Second solution will always be of this kind, x times y1. And if we take this common e raised power minus 4x from this thing, we will obtain here a first degree polynomial. This is your first degree polynomial into e raised power minus 4x, which is basically what? It is the y1 of x. Okay. You know that the roots in this case, roots were minus 4, 4. The roots were repeated twice. ठीक है, दो रूट्स थी, मतलब दोनों आइडेंटिकल हैं. If we have a third order differential equation and 3 identical roots, for example, if we have a third order differential equation, whatever the equation is, and the auxiliary equation is a cubic polynomial, and it has 3 roots, which are minus 4, and minus 4. Okay. In that case, y1 will be what? E raised power minus 4x. y2 will be what? X times y1, means x times e raised power minus 4x. And the third solution will be what? It will be x square e raised power minus 4x. So what we are basically doing here, we are increasing the power of x in यहाँ पे, here we have x power 1, here we have x power 2. If we have another 4, means the root is repeated 4 times, then the fourth solution will be what? It will be x cube e raised power minus 4x. So the number of repetition of these roots, it tells us basically y1, y2, यहाँ पे in fact x power 0 है because it's a linear independent solution. Now this one will be x power 1, this one x power 2, x power 3 by 4. In general, if we have this root repeated n times or k times, maybe n पहले order है, so k कर लिया, k times. If the root is repeated k times, then this solution will go on, so on, and y kth solution will be what? X power k minus 1 times e raised power minus 4x. And if we write in this case the general solution will be of this form: y of x is equal to, we'll write the linear combination of all these solutions. And after taking e raised power minus 4x common, what do we obtain? We obtain c1 plus c2x plus c3x squared plus so on plus ck times x power k minus 1 times e raised power minus 4x. So this function will be a polynomial of degree k minus 1. If the roots are repeated k times, then the general solution will be the multiple of this y1, and the multiple is what? It is the polynomial of degree k minus 1. This is how we generalize the solutions in case of repeated roots. I hope you get it. If you have any question, you can ask me. Now, the third case, when the roots are complex. Let me have some example. This one, yes. Example 3, in which we have complex roots. Now, we need to solve this differential equation: 2y double dash plus 2y dash plus y equal to 0. So this differential equation can be written as 2d squared plus 2d plus 1 times y equal to 0. And the characteristic equation, polynomial equation, basically, polynomial equation is what? It is 2m squared plus 2m plus 1 equal to 0. Now, after solving this by using quadratic formula or factorization, whatever you want, we obtain two roots which are minus 1 by 2 plus minus 1 by 2 iota. So now we have a pair of complex roots which are complex conjugate of each other. Now, how to write the general solution in this case? Y of x is what? It is e raised power alpha. Here, this is your alpha. And what is your beta? This is again your beta. So it is alpha e raised power alpha. Alpha means minus 1 by 2x times c1 cosine of beta. Beta is what? 1 by 2x plus c2 sine of 1 by 2x. So this will be your general solution of this given differential equation. According to the discussion we have done earlier, I told you how to write the general solution in this case. Again, if the complex roots are repeated, for example, we are going to generalize this again as we have generalized the repeated case. If the complex roots are repeated, then how to write the solution? For example, we have a fourth order differential equation because complex roots, they exist in pairs. So either we must have second degree, fourth degree, sixth degree, eighth degree to get the repeated complex roots, or even we can have a fifth order differential equation. We can have four complex roots with two pairs, and the fifth root could be any real root, because complex roots, they exist in pairs. If we have a fifth order differential equation, then at most we can have 4 complex roots, but the fifth root cannot be complex. It must be a real number. Now, I was discussing if we have a fourth order differential equation and we have 4 complex roots, means a pair of repeated roots. Agar aapke paas 4 different hai, then this plus another similar kind of solution will be added here. But if these roots are repeated 2 times, in that case, the solution can be generalized in a similar manner. We have generalized the case in the repeated roots. What we do there, basically, we write this, and we also know that these are repeated, means we have 2 pairs of the same roots. In that case, you have to write here C1 plus C2x. You add a polynomial of degree 1 here with cosine of 1 by 2x. And again, you add another polynomial of degree 1 here, C3 plus C4x times sine 1 by 2x. So this is how we can generalize the general solution when the complex roots are repeated. If the complex roots are repeated another time, we have 2 more roots of which are identical to these things. Then in that case, we have to add a degree 2 polynomial here and degree 2 polynomial here, and so on. Similarly, the roots can be mix of these cases. Means some of the roots may be repeated and other are distinct. Some of the roots may be real and some roots are complex. In that case, basically we mix up the general solution of all these 3 cases and write the general solution of the resulting differential equation. Let me show you one example of this thing. When there are mixed roots, repeated roots, real roots, and complex roots in a differential equation. But in that case, the given ODE must be higher order ODE. For example, if we have, let me see some example here. In case of higher order ODEs. This is basically an example for the higher order differential equations. Higher order ODEs, but they must be homogeneous. Otherwise, we cannot apply this technique. Now, we need to solve this differential equation y 4 dash minus y 3 dash plus 2y equal to 0. We need to solve it. Is there a question? No. How can we write this differential equation? We can write d4 minus d3 plus 2 times y equal to y of x equal to 0. Now, we can write the characteristic equation easily, which is m4 minus m cube plus 2 equal to. This is your characteristic polynomial equation, and we need to find the roots of this fourth degree polynomial equation. How to write the roots of this equation? I hope you know it. If you do not know, you can ask me question. How to find the roots of this equation? Can anyone tell me? Have you already studied these kind of how to find roots of higher degree polynomials? Anyone? Can you tell me? No one is interested. No. From Hassan Tanveer. How to find the root of this 4-degree polynomial? We look at this constant. Okay. This is the constant term, 2. We need to know its divisors. Divisors of 2 are what? Divisors क्या हैं इसके? Plus minus 1 and plus minus 2. So the divisor of this constant terms are plus minus 1 and plus minus 2. So we'll use the remainder theorem, which you have already, you should have already studied in your earlier classes. We assume that this left-hand side is your P of M, where P2 of M, in fact, it is a polynomial of degree, sorry, P4 of M. It is a polynomial of degree 4, and it's a function of M, and it's a polynomial M4 minus M3 plus 2. Now, the divisor, we try these divisors, and we put them here. पहले हमने 1 put किया, ठीक है, 1 power 4 minus 1 plus 2. This is equal to 2, and it is not equal to 0. So m is equal to 1 is not root. M is equal to 1 is not root of P4 of M. Now we try the second one, P of minus 1. अगर आप minus 1 put करें इसमें, you would get 1 here minus plus 1 plus 2. So this is what it is 4. It is again not 0. P of minus m is equal to minus 1 is also यहाँ पे आपके पास there is a mistake in the हाँ एक सेकंड यहाँ पे आपके पास in this equation यहाँ पे आपके पास y dash है. So यहाँ पे y dash है. No, it's not y. तो यहाँ पे आपके पास 2d भी आएगा, ठीक है. In that case, the auxiliary equation is m4 minus m cube plus 2m है, ठीक है. From this equation, we can write m times m cube minus m square plus 2 equal to 0. Now, one root is what? M is equal to 0. Now we need to find the roots of this polynomial. And we again use the same procedure. We see the divisors of 2 here, and now the equation becomes cube square. 1 put करेंगे तो आपके पास again वही आएगा. minus 1 put करेंगे तो आपके पास यहाँ पे यहाँ पे -1, यहाँ पे -1 plus 2. So it is 0. It means m is equal to -1 is a root of P4 नहीं आएगा, P3 है basically, क्योंकि we have a degree 3 polynomial here. ठीक है. Now P3 of m. If m is equal to -1 is the root of this polynomial, then m -1 उधर ले जाएं, plus 1. M plus 1 is a factor of what? M cube minus m square plus 2. If m plus 1 is a factor of this polynomial, then this factor must divide this polynomial of degree 3. अगर ये इसको divide करेगा, तो let us divide it. if we divide m plus 1 and m cube minus m square plus 2, अगर इससे डिवाइड करें इसको तो हम किससे मल्टीप्लाई करेंगे? पहले m स्क्वायर से मल्टीप्लाई करें, यू गेट m क्यूब हियर माइनस प्लस m स्क्वायर, आपके पास ये नेगेटिव हो जाएगा, ये नेगेटिव माइनस 2m स्क्वायर plus 2. Again, we multiply with minus 2m and we get minus 2m square minus 2m. What we obtain here, ये cancel हो जाएगा, 2m plus 2. So now we multiply with 2, we get 2m plus 2. ये negative negative cancel, we get 0. So now this has divided this and the quotient is this. What does it mean? We can write this expression or this cubic polynomial is equal to m plus 1 times this quotient m square minus 2m plus 2. So this is how we factorize that expression, the cubic polynomial. Now, it means this expression, now, this one, which was the original characteristic equation, this can be written, how it can be written as m times m plus 1 times m square minus 2m plus 2 times m square minus 2m plus 2 equal to 0. Now we can find the roots of this 4-degree polynomial. What will be the roots? यहाँ पे एक m0 root होगी, एक m-1 होगी, and then we can solve this quadratic equation by using quadratic formula or factorization, and we can have roots of this thing. After solving this thing, we can find finally the roots. I hope you get it, how to find the roots of higher degree polynomials. मैंने थोड़ा सा नोट्स में भी इसको एक्सप्लेन किया हुआ है. If you people don't understand, you can ask me in the next lecture, or even right now, if you have any confusion, you can ask me. After solving this 4-degree polynomial, we obtain roots, which is m is equal to 0, minus 1, and 1 plus minus iota. So these are the 4 roots. Now you can see that there are 4 roots, 2 are complex and 2 are distinct, real and distinct roots. Then how to write the general solution, or how many solutions do we obtain? We can write a solution for each root. We will definitely have 4 solutions. Okay? But these 2 roots are complex and they exist in pairs. Then we can write the general solution corresponding to these 2 complex roots combined solution. So y1 can be written as what? E raised power 0x. y2 can be written as e raised power minus 1x, and y34 इकट्ठा लिखेंगे ना यहाँ पे, तो आपके पास यहाँ से जो solution आएगा basically, you can say that यहाँ पे अगर आप देखें, चलें अगर सेपरेट लिखना चाहें तो वो कैसे होगा? y3 of x क्या होगा? It will be e raised power 1x cosine of, यहाँ पे भी 1 है तो cosine of 1x, ये आपका y3 होगा. y4 क्या होगा? It will be e raised power 1x again and sine 1x. ये आपके पास 4 सॉल्यूशन होंगे. ठीक है, ये हमने कैसे लिखा? ये दो हमने वहां पे C1 और C2 को सेपरेट कर लिया, क्योंकि दो आपके पास कंबाइंड सॉल्यूशन आता है ना. तो कॉम्प्लेक्स रूट्स के अगर हम सेपरेट सॉल्यूशन लिखें विदाउट कांस्टेंट्स, तो इस तरह लिखेंगे C3 और C4. Now, in order to write the general solution, combined general solution of this given differential equation, how do we write it? We write y of x, which is basically C1, y1, linear combination of all these solutions, C2, y2 of x, plus C3, y3 of x, plus C4, y4 of x. It's basically linear combination of all these solutions. So now, C1, y1, it is C1 e raised power 0, 1 हो जाएगा, ठीक है, क्योंकि यहाँ पे 0x है, plus C2, second solution e raised power minus x, plus इन दोनों को कंबाइन करें तो आपके पास या e raised power x कॉमन ले लें तो आपके पास क्या आएगा, e raised power x कॉमन C3 cosine of x plus C4 sine of x. So this will be the general solution of the given fourth order ODE, homogeneous ODE. I hope you get it. If you have any question, you can ask me. अगर यहाँ पे ये दोनों रिपीटेड रूट्स होती तो फिर कैसे सोल्यूशन लिखते? बेसिकली y1 आपके पास क्या होता, अगर यहाँ पे फॉर एग्जांपल -1 है तो y1 क्या होता, e raised power -x, y2 क्या होता, x टाइम्स e raised power -x. तो फिर उनका अगर हम लीनियर कॉम्बिनेशन लेंगे तो e raised power -x कॉमन आ जाएगा. यू विल गेट हियर अ पोलिनोमियल ऑफ डिग्री 1. I hope you know it because we have discussed it earlier here in the case of real and repeated roots. Now, if you have any question, you can ask me. There's no question. So let us consider this example. We have an ODE of order 10, which is homogeneous with constant coefficients, and it has these 10 roots. 0, 1, 1, 1, 3, 7, plus minus 3 iota, plus 2, plus minus 5 iota. I hope you can write the general solution of this order 10 ODE, homogeneous, by using these roots. I give you a couple of minutes to write the general solution of this differential equation and then show me. I hope you have written the general solution. Can you show me? Or can you share the screen with everyone so that everyone can see your general solution? Where is Taram? Taram. More. Allow to multi-pen rename. No. No. Any other? Can you show me Abdullah Bashir your solution?
जी सर.
वीडियो ऑन करें अपनी. हाँ
सर ये है. नजर आ रहा है?
Show me and keep talking to me.
Okay. Sir, is it visible now?
थोड़ा सा पीछे कर लें. थोड़ा सा. हाँ.
Sir,
Now, can you read it? Can you read it? Yes.
जी sir. Y of x is C1 e power minus 2x plus C2 e power 5x plus C3 e power 3x plus bracket C4 plus C5x plus C6x square bracket close e power minus 3 by 2x plus e power minus x bracket open C7 plus C8x into cos 4x plus C9 plus C10x into sine 4x or per whole bracket close.
Excellent. This is correct solution. Thank you, Abdullah. Taram, have you written? Why are you taking so much time? I think she left the meeting. Okay then, guys, it's sufficient for today. I think in the next lecture we shall discuss the solutions of non-homogeneous higher order differential equations. If you have any question, you can ask me. Otherwise, I'm going to stop this meeting. Okay then, thank you very much. See you in the next lecture. Take care.